could you post also the link to the web page? So there's a template data for the code along. You don't need to have installed anything. It should probably just work in your system. You can use the text editor of your choice. So that's where that data file is. We also have a pre-survey. But like I said, we'll talk about data viz basics and some terminology, and then we'll get around to some charting. And if we have extra time at the end, we can just experiment. So if you have data sets that are ready to visualize, or if you want to try some other things that we didn't cover, maybe we'll have time for that. I'm not entirely sure. Okay, how are we going to do things? Basically, when we're running exercises, it would be really great if you could declare that you are finished by raising your hand. And then when you have a question, you can write it in the chat or use the raise hand feature or direct chat Alex, or add it to the HackMD file, which Alex will be following. All right, so why Vega-lite? Well, this was originally developed for hackathons. ResBazAZ is very similar to a hackathon. And one thing I noticed at hackathons was that most visualizations use basic charts, and some of the projects had streaming data. Vega-lite is very robust when it comes to creating quick basic charts that you can share on the web. It also has support for streaming data, which is not covered in this workshop, but will get you started here. So that's why I decided let's do Vega-lite. It's in JavaScript, which also gives you access to a lot of web things. You can put your charts online. You can also use everything you might learn about HTML and CSS to help you there. The workshop on that is at the end of the week, though. As noted before, there are a lot of visualization workshops this week. And I actually like all of these tools a lot. Maybe this is why I'm a visualization person. But tomorrow there's ggplot, which is in R, Shiny dashboards as well. Wednesday has more pandas, which I saw the people in the previous session working with, and matplotlib, which I've used a lot as well. And Friday also has an awesome thing on observable networks. I think Devin is around. And I assume that's going to be in JavaScript. So that's really exciting. And like I said, Friday also has some more about HTML and CSS. So hopefully this will give you a sense of kind of the broad range of charting libraries that we have. There's probably like 100 of them out there. And I find that when I choose to use one, it usually comes down to what is the easiest for the format my data is in right now, and what defaults do I like? Because it's like, maybe I like these prettier for this paper that I'm writing, or maybe for this presentation, I want to use this other type of chart. So it's nice to have that kind of option with what you want to do with visualization. All right, so I think this is a pretty quick way to get started. So let me move forward. The other thing is, if you want to go at your own pace, if I'm going too slow, if I'm going too fast, I think we're a small enough group that you can just poke at me. But in that zip file on that web page, there's a PDF that's self-paced. It has all the exercises we will do today, and you can kind of take them on your own. The very last page includes kind of a warning. There's this new data set that I've added recently to the example data sets that we're using. I was trying to find something that was small and also not depressing. And so I found this on Kaggle, this data set of the top 1,000 Twitch streamers. We will not get to that in the exercises today, but if you're here to practice more skills with Vega-lite, you could try to replicate this chart that I did here on the right, where it's a dot plot that shows how many followers the mature versus non-mature channels have in every language. So it's a nice way to try to break down how Vega-lite specifies things, and just another fun data set to explore. You can also check out things like followers versus views versus how much time viewing. I don't actually know that much about Twitch, so maybe this data is more interesting to other people, but it seemed reasonable. Okay, so let's talk about data. Most of these visualization libraries have some terms that they use for data, so it's kind of good to know where they come from. So most of the data people use is in some sort of tabular format. And I feel a little silly saying that with Alex as my helper because we worry a lot about non-tabular formats. But if you think about data in a table like a CSV file or a single table database, what you can think of is that every data point, like this entity with attributes attached, is a row in that table. And so you might call this an item or an entity or a record. And then each of these columns is an attribute of that entity or item, or sometimes called field. So field is what Vega-lite is going to use. So in this case, we have these items, and the item is just the row, but it has all of these attributes like product container and ship date and the ID. And then what we're going to call is a particular item and attribute pair within the table is called a cell. All right. So I think the most important thing to know from this one is this idea of attribute and fields. Those get used a lot, but still this idea that there's some item underlying this. All right. Attributes can take several forms. So we're going to break this into 3 categories. There's quantitative data. This you could order like big to small, but you can also do mathematical operations on it. So you can subtract one from another and you get something meaningful and valid. Whereas ordinal data has some sort of order, but not a mathematical relationship. So what you see in the middle of the slide is these t-shirt sizes, right? We can organize them from small, medium to large, but I can't subtract medium from large and get something that means something in this space. And finally, there's nominal data. And this is often called categorical. That's actually my default way of thinking about it, but Vega-lite uses nominal, so I will hammer nominal here. And that has neither order nor mathematical relationships. So the example here is shapes. I can't order shapes, especially when I have things that have the same number of sides going on. Maybe if I was just doing perfect convex polygons, I could organize by number of sides, but in general, shapes do not have some sort of order. So I'm going to call that nominal. Text data often is nominal. So here are some more examples. Quantitative, the things I can do math with. So things like lengths and counts and scientific data and weights, distances, dates, and then some more examples for ordinal, things like letter grades. I can't subtract a B from an A, or Likert scale ratings. I don't know what very dissatisfied minus satisfied means. And then nominal colors also, you might think, oh, Roy G. Biv is how we organize colors. That's a great way to upset a Viz person, but typically not in order to them. Names, blood types, different types of things that have sort of a text value to them. All right. So we should always know if we want to visualize data, is it quantitative, is it ordinal, or is it nominal? Okay. And again, we can do all sorts of mathematical operations on quantitative data. I've been using subtraction a lot, but also things like comparison. And for some of them, we can actually do multiplication and division, but that's not completely required. Ordinal lets us compare, so that order means we have less than and greater than, equal to and not equal, but we can't do plus and minus. And nominal means that we know when things are equal and not equal, and that's about it. Okay. So in this chart that we talked about in the beginning, let's do a quick check. Which ones are nominal? Let's do that one first. Just type in the chat, take a guess, think to yourself. I asked this and then I look and I'm like, is there something nominal in here? So there's kind of a way of looking at it where like the order ID is that I guess you could order that, by the way, in the order in which they came. So maybe we don't have any nominal, but some would see it as nominal. Can you tell me which the ordinal fields are? Right, so product container and order. So order priority has that 1, 2, 3, 4 in there because they really want you to order it. And then product container has that small, medium, and largeness to it. And then so that leaves what are the quantitatives, and I guess you guys both see the dates there as well as whatever product base margin means. So here we go. Again, I warned that order ID appears to be ordinal, but maybe it doesn't actually mean anything because you have the order date that actually gives you order. So nominal is just whatever the database decided to handle it. And then a couple other things to note that, quantitative also has this temporal field, and depending on how fast we move, maybe we'll deal with some temporal data as well. All right, so we know what kind of data we could have, quantitative, ordinal, or nominal. All right, so now that I've talked about the data in this data visualization workshop, I'm going to talk about the visualization part of this data visualization workshop. And so there's something we like to call encoding. It is often also called mapping. And the idea is this is how we get from data to the visualization. We need to encode the data into a visual form. And so there are 3 important concepts with that. They are marks, channels, and the encoding itself. So like I said, the encoding is going to map data to some sort of visual structure. Now marks, these are what we call graphical primitives, and they're going to encode the items. So remember, we said that items are the rows or the entities with which we associate the data with, right? So the mark is going to always represent some sort of item or entity. And then channels are ways we can show different properties or attributes or fields of that particular item. So channels are going to match with fields and attributes. So channels go with the columns and marks go with the rows. So let's look at some examples. So here's this idea of graphical primitive. Most common mark you're probably used to is a point, but we can also use lines and areas, and depending on how the points look, you might think of them in some different ways. We could use bars, that's kind of a form of area, or maybe it's a form of line. But you can really think that whenever you do a visualization, the items are mapped to some sort of mark. Now the channels will describe how those marks looked. Where does the mark go? That's position, right? Am I going to put it over on the right or the left, high or low? What color am I going to make the mark? If the mark has some sort of is non-circular, can it tilt? Will I use a special shape? How big am I going to make it? All of these are choices that are made in the encoding. And these are all chances for us to encode data on it. Okay, so here's a whole bunch of channels. And what a lot of visualization research has done is try to understand which channels people see and can interpret faster. And of course, which channels make sense for which kind of data. So you'll notice on the left, those are the channels that are good for ordered attributes. So those are both ordinal and quantitative. So position on a scale, length, the size, and then notice certain aspects of color. So the luminance, how bright something is, and the saturation to a color. Whereas on the other side, categorical attributes, or as we say, nominal attributes, those map better to channels like the actual hue of the color. So we separate color out into these separate ideas of it based on which attribute makes sense. We can also do things like shape. Maybe we can put things into region. And so a lot of experiments have been done to try to see what do people estimate better in terms of the channels. Oh, and these are kind of in vague order list of how effective they are. So people are really good at telling the difference on position on a common scale. So if you have something important that you want people to see, maybe where you position the marks should be your most important attribute. All right, so now we have this idea of marks and channels and encoding to go with our data of ordinal, nominal, or quantitative. And that's what you need to know to start visualizing in some of these libraries. Okay, so, but first, let's take a quiz, a totally not graded quiz. So let's think about charts. So you guys probably know charts already, you read them all the time. So let's try to think about them in this language of encoding. All right, so bar charts are really good at showing relative counts. What is the mark in a bar chart? Okay, so the mark is the bar. And then what we're doing is we're encoding the number of records as the height, or rather the length, or height and length are the same. So indeed, the mark is the bar. We're using the length or height to encode records. And we're kind of also using the X position here to encode something about time. All right, so our mark is rectangles or bars or boxes. These all mean the same things. And we have a quantitative value, the count, mapped to the height on a common scale. And something about the way we're ordering them is mapped to the x-axis. I'm not sure I would call that a nominal value, actually. Should fix the slide. I think this is more an ordinal value down there. All right, let's try another chart. Oh, but before that, just a little tip. Even though we're used to seeing bar charts in vertical position, it's kind of nice to put them horizontally because that means all of the labels on the bottom, which are typically longer, can actually be written horizontally, which is the way that we read. And so this is the same as the previous chart, but we've just flipped the encoding, right? Now this date value is mapped to the Y position. And now this count is mapped to this length or extent in the X position. And so what's kind of nice about these libraries is also if you think about things as an encoding, you can change the look very quickly by changing what the encoding is. All right, line charts. What is the mark in a line chart? So these are exercises to help you get ready for using a visualization library. The line. Yeah, this isn't supposed to be a trick. And then we kind of have the positions of the ends of that line mapped to the different places in X and Y space, depending again on this date value and the number of records. Line charts are really good for showing trends. One thing that people sometimes do, though, is add lines to charts where things are not actually connected in a trend way. So try to avoid doing that. All right. So we have this temporal value mapped to the X position, and we have the quantitative value mapped to the Y position, and these affect our line endpoints. All right, scatter plots. Scatter plots are really good for showing correlation between two different attributes. What is the mark? Okay, the mark is a circle or a dot or a point. All of these work. In fact, because there are so many different words for this, Vega-lite is going to accept both circle and point. All right, and then what are the encodings of the attributes here? What channels are we using? So we're using color X and Y. And I think this is really good because sometimes you forget that color is being used. So here X is calories, Y is sugar, and color is caffeine. All good things. Maybe not the calories, I'm not sure. All right, so histograms. Oh, I love histograms. Okay, the mark is rectangles. All right, and the channels that we're using. Huh. So thinking about it as areas is interesting because I see how you're trying to use the fact that these bins have some width. The height is definitely the counts, and where the bar starts kind of indicates not where a particular item is, but where like a class of them is. So kind of under the hood, the histogram has transformed your data from individual items to groups of items. And now we're thinking of things in terms of an aggregation of items. So indeed, we have bars. X position is denoting this range, where suddenly this range has taken your items and turned them into some like clustered or aggregated item, and then Y denotes some sort of count. Okay, so I think we've got some idea of how we break down charts now. So let's talk a little bit about Vega-lite. And I think this is the hardest part, personally, is if you have not already downloaded the workshop files. Okay, that's not the hardest part. The hardest part is just opening everything and making sure your workflow works. So what will happen is you'll unzip this file and you'll get a bunch of files in whatever viewer you have for seeing a zip file. There's a file called template.html, and I'm going to ask you to open it two ways. The first way is to open it in a web browser. On some systems, you can double click. On other systems, and sometimes in the same, you can do some sort of right click open with. This is a Mac, so I'm just going to open it in Google Chrome. And what you should do is get a little web page that just says, this is my chart title, and has this little circle with 3 dots on it. All right, so if you're having any trouble with that, please do bug Alex. He just put it in the chat. But like I said, I think this is the hardest part because, you know, it's hard to imagine where everybody's operating system is on this. All right, are you guys good? Can you give me a check mark if some of you are still with me? All right, so at least one person is, 2, 3, awesome, okay. The other thing that you wanna do is also open it in a text editor. So again, you can do this with sort of the right click, and you'll get something probably, unless you have the same Mac Vim as I do, it probably won't look like that, but all of this text should be in there. And so the idea is, much like we do with the HackMD website, we can edit this code in our text editor and reload it in the browser to see what changes. All right, so again, if you're running into trouble doing this, like I tried to open it last night in the text editor for Mac, and I found that that opened the web page look instead of the source code look, which really surprised me because I'm used to opening things in the easiest editor. So hopefully you have something that will open it. Okay. Another thing is, I talked about this little thing with the 3 dots. What's nice about that is that comes embedded with Vega-lite if you want it there, and it'll let you save whatever you do as a PNG or an SVG. So for me, that's really nice if I'm writing an article and want the code in there. But another thing is you can also open this file in what's called the Vega editor. And so this will also kind of give you a side-by-side where you can work on the code and see the chart compile at the same time. So that can be nice. The only downside of it is you're going to have to copy and paste any data you use in there. So oftentimes what I do is I start with the HTML because it's a little bit easier for me to input the data. I reload it and get the chart, and then I immediately open it in the editor, and then all my data is in there and I didn't have to do any work. So a couple ways in which we can edit Vega-lite. All right. So let me tell you a little bit more about what you're seeing. So Vega-lite can be embedded in this web page. Everything in red, you kind of don't have to worry about. This is indicating to the web browser what kind of document you're getting, setting up all the things like what should appear in the tab. In that boilerplate, I'm also linking all the Vega-lite libraries. And so I think when you get started with this, you can just kind of copy and paste everything in this template to what you're doing without having to worry too much about what's going on. Like I said, on Friday, there will be a workshop that will go over a little bit more about what this means. It's all set up, but it's like can seem really intimidating right now. What we're mostly going to be worrying about is this stuff here in the blue, because that's where we're going to put some sort of specification for what we want in our visualization. And so the way you specify Vega-lite is in JSON. Some of you have probably seen JSON before. It's a very convenient data format, but I'm going to go over it a little bit just to make sure that we're all on the same page. Okay, so there are two major structures in JSON. An object, which is not ordered, but gives you key value pairs, so you have a name and then a value with it, and an ordered list of items. I think one of the most important things is this is comma separated. I'm going to hammer on this because I always forget the commas and then nothing works for me. So please catch me missing commas places. All right, so here's a list. It starts with a square bracket. It has a bunch of quoted text values in it. And you notice every single one ends with a comma, except the last one. And then we have the square bracket that ends the list. The other example, whoops. Yes, so missing commas lead to strange error messages. When we go into the live code, I'll show you how to open the console and see what the error messages are. But the thing is, it's like your browser is really bad at realizing, oh, there's a missing comma. Instead, it just goes onward and is like, what is this thing that I wasn't expecting this thing here because there was no comma before it. So when you get a weird error message, the first thing I usually do is think, did I miss a comma somewhere? All right, so we talked about lists. Here's an object. The object starts and ends with a curly brace, much like the list starts and ends with the square brace. And here I have these keys. They're supposed to be in quotes, but sometimes you can get away with not putting them in quotes, colon, and then a value. And these values don't have to be all the same. So here I have 12.2 and something in text and another list and another object, true or false. So you can nest these, and Vega-lite is going to nest these quite a bit, and data formats will nest these quite a bit too, if you're familiar with JSON data. So notice, yes, I have a number, text has to be quoted. This list that we talked about on the previous slide, this one is numbers in this list. Another object, this object only has one key, whereas the object containing it has 5. And then finally, a true or false value, which you may have also heard called Boolean. So we have various things we can communicate in JSON. All right, and then here's this idea where I have a list of objects. So notice, since it's a list, the outside is the square braces, and the inside, because those are objects, are curly braces. Now note the two objects in the list, they both have the same keys. Both have an ID key and both have a name key. So it's very common to see a list of objects as a data file. And in fact, there are lots of utilities online that will convert a CSV into this format. And I find it very readable. And then again, notice since this is a list, there's a comma after the first item and no comma after the last item. All right, so Vega-lite is also in JSON. So what you're seeing here is the Vega-lite specification is an object. There are curly braces on the outside. And then there are three keys: data, mark, and encoding. And we talked about marks and encodings before. And so that data is just a link to wherever your data lives. There's various ways to specify that. We'll go into that in a sec. The mark, we talked about, oh, it could be a point or a circle or a rectangle, and there's a whole list of those. Inside that zip file, there's a file called cheat sheet where I've taken some of the documentation of Vega-lite and put it there all in one place. So that'll give a list of all the valid marks there are. And then finally, this idea of encoding. And inside encoding, which is another object, you have keys and values. The key here in this example is X, and that tells you that X position is the channel we're using. And then inside, there are two required fields. Well, I guess, well, you will talk about this, but field, I talked about, that means something like attribute. That tells you which column is going to be encoded to X. And then type tells Vega-lite what kind of attribute or field am I looking at? Is it quantitative, ordinal, or nominal? And with that alone, Vega-lite is going to try its best to generate a chart with good defaults. All right, let's go a little bit further into this. Yeah, so here the data, the mark, and the encodings. And here we've only encoded X, but we'll probably need to encode at least Y or something else. There are several ways to input data. So you can give a URL if you have a running web page to wherever the data lives. If you're already doing things in JavaScript, maybe you have the name of a variable that contains all your values. Or you can just cut and paste it as the JSON directly. So here the values are given as a list of objects. And we just talked about that. And you notice each of these objects in the list, they all have an ID key, a foo key, and a bar key. So again, very similar to a table. All right, so I can set my mark to be points, but as I mentioned is on the cheat sheet, you have other options. So you probably understand circle and point are basically the same. They'll draw slightly differently. Lines, bars and rectangles are very similar. You could have it be text. And then we have some more that are like kind of a little bit more advanced. And by the end, maybe we'll use that box plot directly. All right. And then what's also nice is that you can add some tooltips, right? So you can give the mark a type, but then you can also add a tooltip to it. And that's what allows you to hover over the mark and get data over it. The one on top just says, tell me whatever this mark is by default. The one on the bottom says, give me all of the data associated with this mark. Because we talked about how a mark is representing an item, and it's going to tell you all the attributes that are associated with that item if you use this. Okay, that was a lot to take in. Let's try a small example. So the way this is going to work is I have this tiny data set. It has 6 values, rainy, partially sunny, and sunny weather, and what the temperature was. And this data lives in ResBazAZ_az.js. So I'm going to flip out of this into live code mode. Okay. Or I guess end show, there we go. That's the way to do it. Okay, hopefully I'm still screen sharing so you guys can still see this share. All right, is the size of this text all right for you? Is there anything getting cut off? Should I be making it bigger? So what my text editor is showing is this side is template.html, the source code for it. And this side is ResBazAZ_data.js. So what this line here is doing is saying, import this file, this ResBaz underscore data.js into my HTML file so I can use it. So this is convenient to me because now if I want to add data to this chart, what I'm going to do is I'm going to do this data. And then what are the data values? I'm going to say that they are small because over on this side, I've labeled this data with the variable name small. And the reason I'm doing that here is just to make it smaller. But I could do it another way where I actually copy and paste the data in, and I'll show that to you in a second. Let's also give this a mark. So we talked about having point. Okay. And then finally, what we said we needed was encoding. And then encoding is an object that's going to hold several objects. We only have 2 data values, so there's not a whole lot to encode. So let me give this X position to, we said we needed a field name. Oh, I should put things in quotes, even though it'll probably work if it doesn't. So the field name, I'm going to say the X position is going to be the temperature. And what type of field is temperature? Yes, it is quantitative. All right, and then I don't put a comma there because I'm about to end things. I do put a comma here because I'm going to put another thing. If I don't say this out loud, I'm going to mess it up. All right, so then let's say the Y attribute is weather. I'm just going to say this is weather. And I don't think this one has a order to it, though I guess you could order rainy, partially sunny, sunny, but there's no way Vega-lite would know that. So we're just going to say it's not nominal. And then I'm going to end this, and then I don't put a comma there. And then I'm going to write this file. And then I'm going to go to my web browser version of this and make this a little bit smaller. Whoops. I'll reload this. Okay, so basically what's happening now is Vega-lite is reading this specification. It knows it's got these values over here, and it's drawing the chart. And just to make this extra explicit, I'm going to show you that you can do this several ways. So I'm going to cut and paste this value list from over here into this document. That's going to be kind of nasty looking because I just cut and paste it, but we'll leave it like that. Oh, and I should get rid of this extra semicolon. All right, so this is just me having the data directly. Let's reload this and see if it works. All right, I didn't get any errors, so I'm going to assume it works. But just to make sure we're still paying attention, it's still paying attention to me, I'm going to change this point to a bar and see if it updates. There we go. So now it's turned into a bar. One thing you might notice is that there's 6 data points over here, but only 3 bars, right? Though you can see they're like these little chunks of bars. So what's going on here is Vega-lite's not really sure what to do with the fact that the weather is being aggregated like this. So it's just appending the data. It's basically adding. What I can do is tell it to, oh, these are aggregate. I'm going to tell you to aggregate the data in some other way. So I can tell it to aggregate. And then I'm going to say, take the average. So we'll reload, and now it's taking the average value. You see it redid these lines down here. And now instead of having like these 3 little bars that are right next to each other, it's giving us, or instead of having 3 little bars stacked on top of each other, it's giving us these separate bars. And I told you I'd also show you this. So here's me opening in the Vega editor. I'm going to open this a little bit further so it has plenty of room. And so what has happened is it's imported my specification with the values included. And then when I run, it'll give me the same thing. I don't always like how it indents, so let me put these files a little bit more easier to read. Because I want to show you again what happens when I remove this average line. So I run this, but then when I remove this average, it's going to, oh, it doesn't draw, it changes them so that they're stacked on top of each other. So it's changed this. And then again, I can change this back to point. So maybe some of you will like this better. And when it's point, it knows like, oh, instead of stacking them on top of each other, I can draw these points individually. So there are 3 sunny points, 1 rainy point, and 2 partially sunny points. All right. Are we following? How's everybody doing? Are you able to follow along, make it happen? All right. Okay, so that gives us enough to maybe get started on our next challenge. So instead of opening this again, I'm just going to make this very large. So here's the next challenge, which is to replicate this Starbucks chart. And so I'm going to start so that you have the right data, but then you change the rest of the spec. So what I'm going to do here is I'm going to remove this values thing that I did to change to the Starbucks data. It's just call it drinks. Oh, no comma there. And that's going to give you this data down here. Each of these are the same. So you see you have quite a few values. All right, so on your own, take a few minutes and try to get Vega-lite to recreate this chart. The filled in things really mean that they're using circle instead of a point. So I will also give you the hint that this is circle. All right. And again, if you have questions, you can DM me or Alex and like give me a check mark when you're ready to move on, and we'll go over the answer. You can give me the check mark whether you've done it or not, just when you're ready. How would I use each data point's index in the data set as the X encoding? So since the ID is unique, I think you could just over here put the field to be ID. Do you mean it like that?
I'll just unmute. Yeah, I think that would work in this case, but if your data didn't have one of those ID fields, do you know a way to leave out the X encoding and what the default might be?
Because that's what we have kind of in this case. To do one individually. I don't know that off the top of my head.
No worries.
Cool. If you find that out, please let me know. Feels like there should be a way to get to the array index, but I'm just not sure.
Yeah, I'll keep looking into it, but feel free to continue.
Okay, well, I'm not sure if we're just at the end of the day or if people are chugging along, but I'm happy to go through this one. So let's see. Jump in and tell me to stop if you want me to stop. All right, so here the x-axis is calories. So I'm going to go back to the x and put in calories. And calories is a quantitative. Did I spell that right? All right, and we're not aggregating that. The y-axis is sugars with a G. So whoever made this data set put the units in the field name. So I have to remember that. And that's also quantitative. And then I mentioned that we wanted a tooltip here. So that's several slides back, but that means I have to put it with the mark. So I'm going to say the mark type is circle. And the tooltip is, I think, content. Let's see how well I memorize this. Data. And I need a comma there. That's where I'm often going to forget a comma. All right, so I'm going to save that. Go back here, reload. Oh, and I don't get anything. So I'm going to right click and inspect to see what's going on. That'll bring up a whole bunch of stuff about the web page. I'll go over the uncaught promise. Oh, that's definitely somewhere where I've done something that would make sense, but doesn't. All right, where might that be? Okay. Let's see if I actually got my tooltip spec correct. So I'm just going to go actually back through these slides. Tooltip, content, data. So that looks fine. Okay. Field of calories, field of sugars. Okay, I can't spell clearly. Quantitative. All right, there we go. There we go. Thank God. But that's good because I got to show you the console. All right, and now if I hover over any of these points, it's going to actually show me the entirety of the data set because I used that tooltip equals data. So that's a very nice way if you want to create something to explore that also has this nice mouse over capability. All right. Now that we've done that, whoops. Note that there's a whole lot of other things that we can use. So we've been using X and Y, but we do have things like the color, the opacity, what the stroke looks like, the exact size, the exact shape. And again, you can find these on Vega-lite's site, or you can find them in the cheat sheet that we used. So given that we have these other encodings like color and size, why don't we try to encode caffeine onto the scatter plot that we've already used? So I'll let you guys have a couple minutes to do that. Okay, so I see some of you guys are feeling ready. All right, so let's just go over what the solution might be. This is just another channel. So I'm going to add this comma. Watch this, I'm not going to forget the comma at all this time. This is me getting cocky. Let's start with size. That was the one on the left. The field is caffeine. And the type of this is still quantitative. And today I will spell quantitative correctly. And we end there. Going to go back and reload. Oh, yay. And then my tooltips and everything still work. And I have the size. I'm just going to go ahead and do color directly on top of that instead of keeping them separate. So color, field. This is still caffeine. Type, quantitative. So I'm writing all of these encoding rules right here. And then the rest of the things I'm not specifying is just selecting defaults for. So here, instead of having a color bar, since I also have this side field, it's like combined color bars for me, where the really dark stuff with a high caffeine is over here, like espresso. And then like the low caffeine, tiny, hard to read stuff is over here, like hot chocolate. Chocolate doesn't have as much caffeine as I like to pretend it does. Okay, that kind of sad. All right. Okay, so great. I think we're all pros at encoding now. Great. So I kind of showed this in the very first tiny example, but you have a lot of options for aggregating data. So maybe I don't want to see all 75 points or however many I left in this data set. Maybe I want to aggregate them along some sort of field. So something like the count or the average or the median or mean or average, because Vega-lite is nice enough to realize you might want to use both, the min and the max, standard deviation. So binning is something that histograms can do, so you can look that up as well. But this is also a way to just aggregate your data and try to understand trends at that level. And that's on the encoding. Another note that says, oh, instead of just encoding everything that you could possibly do, aggregate. All right, so let's take an example where we go from scatter charts, which we've been drawing, to a bar chart that's going to tell us, based on the beverage category, what the average number of calories is. So I'll give you a couple minutes to do that. And if you get bored, go ahead and discover other things about Starbucks drinks. Like maybe instead of the average calories, you actually want to know, I guess, the max, perhaps. Maybe you want to take account of these kinds of things. feel like since there's fewer of us today, we're actually blazing through this. So for those of you who have interest in specific kinds of charts, keep them in mind so we can figure out what to add at the end on the fly. Or if everybody's just super tired, that's fine too. I have barely checked out the Twitch data, so whoever wants to guide that, let me know. But I do think making a dot plot with those was a lot of fun last night. All right, so that was a couple minutes. So back to my data. All right, we're trying to make a bar chart, is it? All right, so I go back and change this to a bar. And now I want that list of beverage categories along the y-axis. So I'm going to change this to beverage category, which is nominal. And it's average calorie. Oh, I should probably not be swinging this code around. Average calories. So what I have to do here is aggregate, and then we said average, right? All right. Was there anything else? I think that's what we said we do. I'm gonna leave, size doesn't really make sense, so I'm gonna leave that. But maybe I leave color on and see what, I think with color, I also need to aggregate for it to be meaningful. Let's see. Well, I'll try aggregating now and then play with it differently later. Oh, aggregate, average, okay. We'll reload. All right, the bars look the right size, even though I did this average calories. And then you notice what happens to the tooltip, right? The tooltip I didn't remove, but the tooltip used to be showing all of the data, but now it can't anymore because, or rather it's showing all the data, but we transformed the data set by aggregating it. So now it's showing for this new aggregate thing we created for beverage category, I'm showing you the average calories and the average caffeine in them. So clearly coffee is the way to go if you want a bunch of caffeine on average, probably because there's only 1 or 2 data points in there. Okay, let's again remind ourselves what happens if we don't aggregate one of these fields. So what happens then is I get this stacked bar chart where it's trying to come up with these different categories that that depend on how much caffeine there is. So what this has done is it knows that caffeine is in separate values. It does see that certain drinks have the same amount. So there's quite a few drinks in this category that have 175 caffeine. It's bringing them all together, and then it's taking those average calories and appending them. So this can be a little bit hard to read, right? So like this doesn't mean that frappuccinos have an average calories of 1,000, even though it feels that way sometimes. What it means is it has this much average calories, 295 for the 110 caffeine, this much for the 100, this much for the 95. Maybe this color isn't the way that we actually wanted to color it because it's hard to see. What if I changed this to say it was nominal? So I'm going to treat those caffeine values as calculating not as quantitative anymore, but as nominal. And so when I treat them as nominal, what happens is it says, oh, well, we talked about on those slides earlier, clearly, that hue is better for nominal data. So it's automatically going to change these to hue. And now you can see, oh, 150 and 25 map to the same thing. This is a problem with using hue. but it makes it more obvious what it's doing in terms of stacking these different average calorie counts. So one thing to watch out for, but also, hey, we just learned how to do a stacked bar chart. Okay. So now let's put a bunch of things together. Let's actually change from showing me average calories to show a box plot that tells us more about the distribution of calories in each of these beverage categories. And what's happening here is we've also decided to override the scale to do something very pretty. And you can do that by adding this scale parameter right here to your color encoding specification. All right. Of course, this chart isn't using red and blue. I just wrote that there because that's what fit on the slide. How would I make the legend a rectangular gradient? I think I'd actually, so what's nice, I think, about a lot of visualization libraries is all of this stuff it does automatically, right? It's made this legend automatically circles for you. I'm not entirely sure why it chose that in this case, maybe because of something about the data. What's interesting is earlier versions of Vega-lite, the default of this would have been a rectangular gradient. But in the most current version, which is what's linked in your template, something about it has decided circles make sense. However, for all of these, if you ever want to override the defaults, there tends to be a way to do so. So what I would do is look up what the legend parameter is and see if you can force it there. But I do not know off the top of my head how to do that for this particular example. By the way, are you going to go over D3?
Oh, in my observable thing?
Yeah.
Well, I think Alex and I are going to do a couple of different things. Probably not doing like a whole workshop on D3 and observable.
Yeah, I'm just thinking about like Vega-lite is one of the things I might go to make a chart for an experiment I run, but most of the time I'm like, I'm not making charts, so I'm spending more time in D3. So I think it really shows which parts of Vega-lite I know well and which parts I don't.
Oh yeah, totally. I'm actually one of our examples of things you can do in observable is your Vega-lite workshop. So.
Okay, cool. All right, I see the check marks changing a bit. Okay, so I see Alex is pasting solutions into HackMD. Thank you, Alex. Another thing is in that zip, there's also an HTML called solutions.html that has all of those listed in there for you to check out at any time. If you run it, it will only show you one thing, but you can copy and paste the different specs into the thing that you're currently running or into the Vega-lite editor. The Zoom controls are now fighting with me over here. The part here is you'd have to cut and paste the data yourself. Oh, another thing I like about this is I can just collapse the data very quickly when it gets put over. So here, I open a Vega-lite editor. You notice this data thing is very big, but I can go boop and make it small and then see the spec that I'm actually working on. All right. Okay, so let's try to do a box plot like this. So I'm going to, we talked about how box plot is a mark in this, so we can just use that. Yeah, the Vega-lite editor, the video editor is really nice, except for the whole, how do I get my data in there nicely? All right, so we're still doing beverage category on the y-axis. How do you restrict the color axis? Oh, that's a good question. So I believe we're doing a scale. And you notice there was this range parameter, which I guess we're saying is purple to orange in this case. If there's a range parameter, there's also a domain parameter. And so what we can do is say 5300. I wonder if I took that screenshot when I had done that and then forgot about it. All right, we still want to do color as a quantitative field. So I'm going to change that back. And then I think we're still doing average. Oh, we don't need to actually aggregate this anymore, but I can probably leave it there and it'll be fine. Let's save this and then discover what has happened strangely. Okay. Oh, how am I? Why is this breaking up into many different things? Oh, maybe it is because I'm aggregating those. Okay, let's, what strange thing have I done here? So I'm going from purple to orange. Oh, maybe I am doing, oh, it's because this turned into calories. All right. Oh, and I did actually need that aggregate. Or actually I needed it over here. It's gonna be a long day. All right. Yeah, because I'm still aggregating in the Y with this beverage category because I have multiple in each one. If we're going to color, I have to tell it what it needs to color by, and that's the aggregate. But the X is going to be determined by the fact that this is a box plot. So I don't need the aggregate there. Oh no, I've done something terrible now. I'm going to go to inspect. Unexpected string. Oh, I thought I was going to get through this without a comma error. Yes, it is right here. There is no comma. Yeah, so unexpected string almost always means, oh no, I forgot a comma somewhere. All right, there we go. So, and we still have these tooltips, but now the tooltip is actually telling us something about the box plot itself. So it's telling you what the max is, what the third quartile, the median, the first quartile, and the minimum is, along with the category and the average calories that are used for the color. So we see that like somehow the signature espresso drinks are much higher than, or I guess they have a wider range than the frappuccinos, which is what I expect to be the most heavy. The light blended coffee, you can see that like there is actually a big difference between those. So this is also kind of the smell test. The data makes sense. All right, so again, what we did here is we changed it to a box plot. Because the box plot kind of naturally aggregates, we don't need this aggregate field in the X anymore. We could leave it there, it would be fine. But over here with this color, what we did is we definitely need to keep that aggregated because otherwise the color isn't going to know what it's supposed to do. It can't derive that from the fact that it's a box plot. And then we set this range from purple to orange because otherwise it'll default to white to blue. And to get rid of that, that 0 level, we made the domain 50 to 300. Another thing we could do with this is a way to like, this means that everything 0 and below, because I think does coffee not show up anymore? Is it just tiny? So can't really make a box plot off of one data point. All right, so this gives us a lot of power, and one nice thing to do with a color range is instead of having it fit the whole range, maybe you want everything 100 and under to show as deep purple, or everything 300 and over to show as bright orange. And so you can sort of change where things are going to clip that way, and that can be a really useful way to show something important about what the data is. Okay. Said we would get to histograms. So when we do histograms, we're going to tell Vega-lite, please bin this particular attribute. But then when we do that, we also have to take the count from that bin and put it somewhere. So this count is a different aggregate that we're going to use to make up for the fact that we binned the data. So in the previous example where we were using beverage category, it was automatically aggregating that because multiple data items had the same value. Here they don't have to have the same value. We could decide on that it should bin. It will try to do that automatically. But whenever we do that, the other things that depend on that attribute also need to be aggregated, much like we did with the color on the previous example. And here we want to use count because that comes up from the bins. All right, so let's all do an example of this now that we have the ability to bin. All right. Alrighty. So you guys set? This is the toughness of doing this online. Okay, well, I'll start moving along with the fact that I realized I had never been changing the title. So now I'm going to actually do that. Distribution. Oh, maybe I shouldn't have done that. You can all see my bad typing now. Calories in Starbucks drink menu. All right, and now we're back to bars again. Whoops. Okay, and now we talked about how this time we're going to set this. Oh, I can't believe this worked with this comma here. Did I add that? I don't know. All right, so bin true. And then what we talked about is why now is like a quantitative value, but it's not really an attribute anymore. It's like a derived attribute. So we're going to say, so now I warned you that almost always we have a field in the encoding, but here we don't because we don't really have the field name. Vega-lite is going to derive that itself as long as we tell it it needs a count. All right, so we're going to save that and we'll see how it goes. And I didn't change the color, so this is so pretty. But indeed, this makes sense. So I've binned along the calories. I've changed my y-axis to records. It's going to now show you what the bin extents are in the tooltip, as well as the average, which is what it's using. And now that Devin's gone, it's going to mysteriously change back into this gradient from the individual circles. Maybe that has to do with the points that maybe for box plot, they decided that points would be better than bars. That doesn't really make sense to me, but I don't know. I'll have to look into the changelog. But because I left the color here, you can see that this also kind of makes sense. And then these values that go above this 300 are kind of extended over there. And so this gives us the histogram that we wanted. So that was binning along the attribute we wanted to bin, and then switching this y to not really have a field, but have that derived count. Okay, so scatter plots, bar charts, histograms. Now let's actually look at some line charts. And we're going to change data sets here because the Starbucks data doesn't have any temporalness to it. And so what you see in this example here is this UFO sightings in Arizona. What I find interesting about this data set is I scraped this off this place called newfork.org, but it has since been imported with everything, not just Arizona, into Kaggle. So you can get an up-to-date and much bigger version of this data set there if you're really interested. And it's neat because they each have these like individual discussions of what was seen. All right, so the idea with temporal data is you can also tell Vega-lite something about what you expect the unit of time to be. So here I'm saying year and month because the UFO sighting data is multiple years and multiple months, and I want it by month. And then instead of saying quantitative for the type, I'm giving it this extra information that this is actually temporal. And again, I can aggregate by count because I'm going to have several of these per month. So if I do this kind of encoding, then I can get this kind of line chart. So let me show you what this looks like in the data. I'm going to scroll past all these Starbucks drinks to the data that looks like UFO sightings. I'm going to change this title to something about UFOs. I'm sure you guys don't want to see me type weird stuff for a while, so I'm just going to make it UFOs. Oh, and what did I call this data set? I believe it was UFOs. All right. And so now we're going to switch to line. And then, as I said, I'm going to switch to something called temporal. That's going to tell Vega-lite a little bit more about the data, as well as the fact that I'm saying date. And then finally, I'm not binning anymore, but I have this idea of the time unit. And we said that was going to be year month because I have year and month. Vega-lite's going to be able to process this date format. And then Y again becomes the count. So that's how many of each of these records it's finding. I don't know what I want to map to color anymore. So I'm just going to remove this for now. Have to think a little bit harder about the data to do that. And I remove that comma at the end. And then I reload, and that doesn't look quite right. What has changed? So aggregate count, type quantitative. This is all the same. Time unit, year, month. Have I used the wrong mark type? Or is it no longer doing what I expect it to? Let's think about this. No while since I did this.
Capitalization?
Yeah? Huh? Oh, did I mess up the capitalization and get the time unit wrong? Is it like that? All right. Oh, there we go. Okay, so Vega-lite wasn't able to interpret what I wrote because I had made this T capital. All right, so I've had a comma error, a capitalization error, and a spelling error. This is good. I'm running the full gambit. All right, so again, the point of this example is partially to show you what a line chart does because line charts are good at showing trends over time. Though as you can see, UFO sightings are not particularly trendy. I don't know, if you download the full data set, I wonder if UFO sightings have gone up or down during the pandemic. I think this is just kind of a random sample. There was a point where I thought like, oh, monsoon season, it goes down during monsoons, but no, that wasn't actually correct. So some ideas with temporal data. All right. And then here's just another, like, we have a different data set. Can you, instead of doing this as a line chart, can you do it as a bar chart, which I think is a little bit easier to read? Okay, see some check marks. All right, so going over this together, it's switched from year to month with this one, but I've also kind of flipped the X and Y axes. So I'm going to be lazy and just make this X and this Y and change this into a bar. So that's like another thing I told you in the beginning, to switch X and Y to make the bar chart easier to read. Let's try reloading. And there you go. Because this wasn't actually a big change in terms of the specification, but gives you sort of a vastly different looking chart. Okay, so those were the examples I wrote down already. I said we could have some free exploration time at the end, though the person who asked about the Twitch data is no longer here. I'm kind of, this could be, if you don't know what you want to try doing, wherever I put that example, I think all the way up here. If you want to try to do this chart, that's definitely a challenge. To do it, you'll need to add another line like this. And then what I'm going to do is put here, I believe it's Twitch all is the extra data set. Just to be sure, I'm going to load Twitch all.js here. Right. And then that would become Twitch all there, and that's 1,000 records. However, if you want to tell me more about scatter plots or Starbucks or UFOs, this is the time to do so. Or if you have your own data that you're having trouble getting into the right format, this is open exploration time. This is also not something I'm taking attendance for. So if you want to like get food and leave, that's fine too. But here's the challenge. I think this one's a little bit tricky to think about, how do I get both of those circles on the same line? But you have all of the pieces to do it with what you have now. Yeah, thanks for attending. And for sure, if you have other visualization questions, we have a lot of people in the ResBazAZ community and in computer science, which is where I'm from, who love visualization. So please reach out whenever. Great. I'm so glad you had fun. Well, thank you so much. Okay, so for posterity's sake, I think I should try to do this one last one with the Twitch data. All right. So I'm gonna retitle this. Just, what did I don't think I even had a title there. So we'll call it Twitch, Twitch followers by content and language. So this is point data. And what's going on is on the y-axis, we have this idea of what language they're using, which is nominal. delete that comma. And on the X, we have followers, field, followers. Okay. And this is going to, we're going to aggregate this by, I think I did max in this example. Let's look at that again. Yeah, max of followers, it generated automatically. So I'm going to say aggregate max. Now this alone isn't going to quite give us what we want. So let's reload this. Oh, that's exactly not going to give us what we want for sure. Where have I messed up? Unexpected string. Okay, it's the end of the day. I'm allowed to make these errors. Here we go. Missing comma right there. Reload, and so that's giving me one circle, but I want things broken out by whether they're mature content or not. And you notice in the original, I had orange circles for one and blue for another. So what I'm going to do is add a color field. Whoops. And then I'll make the same mistake. All right, so field, I have this idea of mature. And then type, I'm going to say that's nominal. Okay, I got all my commas. And now when I reload, I have both the orange and the blue dots. However, what you notice is this is kind of in alphabetical order by language. So that's a sensible default, but I'd actually like it to organize by what the max follower count is. So there's another field, if you look up in the documentation, called sort. I'm going to tell it to do the opposite of the x-axis. And then I reload and we have the same chart. So all this did was change the order of the y values. All right, and now we've done our dot plot. Okay, that's all of the exercises I put together. So I'm happy to take any questions, or if you guys are all set, then have a wonderful rest of ResBaz, and please have fun at all of the other visualization and all the other different kinds of workshops. Great, thanks. Thank you for coming.
Okay, I think that's down to, I think, Grace, you mentioned earlier that there was some trouble getting the Vega editor to open. If you're still on, we could maybe try to figure that out, but we could also do that another time. I think I sent you my email address if another time works better to figure that out, or now works too. Whatever works best for you. Yeah.
All right, great.
That's just fine. Awesome. Thanks again for coming.
All right, bye-bye. I guess you should
Okay,
save the cloud or whatever.
figure out, make sure I don't lose the recording. I will message Austin really quick just to make sure that I don't ruin anything. I think he's saving it, but
I think saving it to cloud makes it easy for everybody.
okay, yeah, if he's doing
if
that,
that's what
then
you're doing.
yeah.
I'm gonna go fix these slides. Oh, it's just us now, so I think you can. Oh, you're off. That's being awesome.